In this video, we're going to cover a beautiful concept from the vector world called projections. So let's make some vectors. We have this green one, 5 I cap, it's along the positive x-axis. And we have this blue one, I cap plus j cap, it's making an angle of 45 degrees with this one. Now, how do projections work? Now for that, we can visualize it like this. Imagine from the sun, the rays are falling on this blue vector, and there's a shadow being formed on this green vector. This purple vector is the shadow of this blue vector on this green vector. And this is called the projection vector. So this is the projection vector of I cap plus j cap on 5 I cap. It has a magnitude, this is the length, and it also has a direction. So let's find this projection vector. Let's take this triangle. In this triangle, this angle is pi by 4. What's this blue length? That's the magnitude of this vector, I cap plus j cap. That's square root of 1 plus 1, that's root 2. Now we can apply trigo and we can get the magnitude. That's going to be equal to root 2 times cos of pi by 4, that's equal to 1. So the magnitude of this projection vector is equal to 1. And what's the direction? Well, we can get the direction from this green vector because that's how we have defined it. This is going to be along this green vector. So the direction comes from the green vector. This is 5 I cap. So the direction is going to be I cap. That's along the positive x-axis. For the direction, we use the unit vector. So we have the magnitude and we have the direction. We can now create our projection vector. That's going to be 1 times I cap. This is the projection of I cap plus j cap on 5 I cap. Now sometimes we're only concerned with the magnitude and we don't care about the vector. All we need is the length of the projection. So how do we figure that out? For that, we can take the magnitude of this blue vector, that's mod of I cap plus j cap, multiply it with cos of this angle, cos of pi by 4. This gives us the magnitude. And when we need the direction as well, when we need the vector, we multiply it with 5 I cap by 5. This is a unit vector along this green one. I've deliberately written 5 I cap by 5 because this will help me generalize this for the formula. Now, when we have magnitudes of vectors and angle between them, especially the cos of the angle between them, we can get to this using dot products as well. So another way to write the magnitude would be this: I cap plus j cap dot I cap. Now look at this dot product carefully. This has two parts. The first one is this vector I cap plus j cap, this blue vector. This is the one that we're taking projection of. This other one is a unit vector. This is the unit vector along 5 I cap. So this is the unit vector along this green vector, the one that's serving as the base, the one where the projection is happening on. Now when we take the dot product, we get mod of I cap plus j cap, that's this part, mod of I cap, that's equal to 1, times cos of the angle between these two. And that's still going to be pi by 4. Angle between this blue one and the green one is same as the angle between this blue one and a unit vector along the green one. So this should give us the magnitude of the projection. And if we want a vector, we'll just multiply the magnitude by the unit vector along this. That's going to be I cap. So this is the magnitude times I cap. This gives us the vector. Now let's generalize this. We have these two vectors and the sun, of course. We have the rays and we have the projection. So let's name them. This is theta, A vector and B vector. We want to find the projection of A vector on B vector. So let's bring this triangle out. We have these sides. This is the angle between them. This length is the magnitude of A vector. That's mod of A vector. This is what we need. This is the magnitude of our projection. So how do we figure that out? Again, using trigo. Magnitude is equal to mod of A vector times cos of theta. So this is the magnitude. And what's the direction? The direction is the same as the direction of B vector. So we can get that from B vector. Direction of projection vector is the same as the direction of B vector. And what's the direction of B vector? That's going to be a unit vector along B. We can call it B cap. So B cap is the direction of our projection vector. We have the magnitude, we have the direction, we can form our projection. So the projection vector is magnitude, that's mod of A vector cos theta, times direction, that's B cap. So this is our projection vector. Let's write this down. That's mod of A vector times cos of theta times B cap. And what's B cap? We can get b cap by dividing b vector by its magnitude, because b vector is mod of b times b cap. So b cap becomes b vector divided by mod of b. And again, we can see dot products here. To get the magnitude, we can take a vector dot b cap. Again, the dot product has two parts. The first one is a vector and the second one is b cap. That's the unit vector along the b vector. So that's a vector dot b cap. We can replace b cap by b vector by mod of b. So that becomes a vector dot b vector divided by mod of b vector. So this is the formula for magnitude of the projection. And if we don't want the magnitude, if we want the entire vector, we can just multiply the magnitude by the unit vector along this. That's b cap. The projection vector becomes magnitude times direction, magnitude times direction. Now that we have the formula, let's look at some special cases. What happens when theta equals to 0? What happens if this a vector is lying along the b vector? Well, then the entire thing will be the shadow. The shadow will be, or the projection vector will be a vector itself. What happens when theta is pi? Imagine a vector facing the opposite direction and lying on b vector. So if you think about the shadow, the length will be the same, the magnitude will be the same of a vector, but the direction, because we want the projection to be along b vector, this is going to be the opposite of a vector. A vector is facing left and b vector is facing right. So the projection will be minus a vector. That's going to be in the opposite direction of a. And what happens when theta is plus minus pi by 2? So if it's exactly 90 degrees, there will be no shadow. This means the projection will be a 0 vector. Now let's practice applying the formula. Let's look at a problem. A vector is 2i cap plus 3j cap plus 2k cap, and b vector is i cap plus 2j cap plus k cap. And the question is, we want to find the projection of a on b. And the second part is, we want to find the projection vector of a on b. So if just the projection is written, it's probably asking us to get the magnitude. And if we're asked the projection vector, we'll get the entire thing. So pause the video, try this on your own. Okay, so for both of these, we need b cap. So let's find b cap. That's going to be the unit vector along b. So b is i cap plus 2j cap plus k cap. Now divide that with the magnitude. That's square root of 1 plus 4 plus 1. That's going to be 4 plus 2 is 6. So that's 1 by root 6 times i cap plus 2j cap plus k cap. So now we have a unit vector along b. Now we need the projection of a on b. So we'll take a vector dot b cap. So a vector dot b cap, that's going to be 2 times 1 by root 6 plus 3 times 2 by root 6 plus 2 times 1 by root 6. So 1 by root 6 common, that's 2 plus 6 plus 2. So that's 6 plus 4, 10. That's 10 by root 6. So this is the magnitude. And if we want the projection vector, we'll multiply this magnitude with the direction. The direction is b cap. So multiplying this with b cap, that's 1 by root 6 times I cap plus 2j cap plus k cap. So this is a number, this is a vector. This becomes root 6 times root 6, that's 6. 10 by 6 is 5 by 3. So the projection vector of a on b, that's going to be 5 by 3 times I cap plus 2j cap plus k cap.